Here we are talking about yet another exciting category of macromolecules that are involved with nutrition, and that is everybody's favorite, lipids. We're also going to be talking about fats and oils. So let's jump in. Make sure you watch this wonderful video by Paul Anderson of Bozeman Science. You bet information that's in this video is fair game for any assessment. It's a good overview, so I would watch that. And when you talk about lipids, yes, they are the macromolecules. Yes, they are carbon-based because they are organic, and they are also insoluble in water. Fats are the lipids that we're going to find either in the body or in foods. Those will be mostly triglycerides. 99% of the fats that you're going to find in our bodies are triglycerides. Oils are going to be lipids that are liquid at room temperature, with the exception, I think it's the only exception, of coconut oil. The three major types of lipids, which you need to know forever, are triglycerides. All triglycerides because they have a glycerol backbone, and then they have these three fatty acid chains hanging off the side of that backbone. Phospholipids are going to contain a phosphate group. Remember the phospholipid bilayer of the cell membrane? Yes, indeed. These phospholipids are forming that phospholipid bilayer. And last, but without a doubt not least, sterols are going to be naturally occurring steroids that are unsaturated. Fatty acids are the carbon-based chains that are going to be attached to the glycerol backbone of a triglyceride. They'll have a lot of hydrogens hanging off those carbons. And there will be an acid group that will form, let me come down here. Here we go. Here's the acid group that will form the connection in between the glycerol backbone and this fatty acid chain. So if you take a look at the left, the structure, the part of the structure that's on the left is going to be that glycerol backbone. And the chain is going to be hanging off that backbone. There will be three for triglycerides. And the connection will be through that acid group, that COO group. So let's come back over here. Here we go. Okay. Now, the length of fatty acids is between 4 and 24 carbons, and they're in even numbers. I can't remember why. I don't even know if I ever knew why. The most common that you will find in what you eat, and the most important of those that are used for our bodily functions, are 18 carbon fatty acids. And these fatty acids can either be saturated or unsaturated. And if they're unsaturated, they can be mono or polyunsaturated. What the heck? Stay tuned. If you don't remember or you don't understand what that means, we'll be going over that. Triglycerides supply over twice the energy per gram than does either proteins or carbohydrates, come to think of it. And I already mentioned that 99% of lipids in the body are triglycerides. So why do they supply so many more calories? Because they have way more carbon and way more hydrogen molecules relative to oxygen than the other macromolecules. We went over that. It's the bottom of this diagram. You can see a monoglyceride. All that means is there's a glycerol backbone and a single fatty acid chain. Tri means 3. So when you hear triglyceride, single glycerol backbone and 3 fatty acid chains hanging off that. So very few of our fatty acid friends are going to be free in food or free in the body. They are generally incorporated into triglyceride molecules. They are the major storage form of lipid fuel for most of our cells. Our adipose cells, those adipocytes, can store an unlimited amount of triglyceride. Once your fat storage cells fill up, they're going to divide, and you're going to have additional fat storage cells, and they're really good at that. This shows you what's happening with a combination of a glycerol backbone and 3 fatty acid chains, making a lovely triglyceride. And we'll continue on with more fun facts about fat, oils, and lipids in the next section. So stay tuned.